In this video, we are going to discuss how to find the solution of an equation using genetic algorithm. I'm going to code the solution in Python language, and the equation I'm going to use for this video is this: 6 multiplied by x raised to power 3 plus 9 multiplied by y raised to power 2 plus 90 multiplied by z minus 25 is equal to 0. I have to find the value of x, y, and z such that when plugged into this expression, the answer becomes equal to 0. For that, I have to create a function in which I'm going to pass x, y, z as parameters, and it will return the value of this expression when x, y, z are plugged into it. Second step is to make a fitness function. The fitness function basically is going to help us in determining the fitness of the solution. The more it is closer to 0, the more fitness it will have. It will help us in the ranking process. I will have to call the function that I have mentioned earlier into this. I have to store its answer in ANS variable. If the answer becomes equal to 0, which is our desired value, I'm going to return a fairly large number. This will help us in the ranking part. Else, if the answer is not equal to 0, I'm going to return an absolute value of 1 divided by the answer. I am using the reciprocal term because the larger the answer, the more it is deviated away from 0 and the lower rank it will have. It will help us in ranking. The answer that is closer to 0, which is small, it will have a higher rank. That's why I have used the reciprocal term. Next, what we have to do, we have to create a solutions list. And I'm going to randomly generate these solutions. The solution will be in the form of tuple because we have the value of x, y, and z. So for that, firstly I have to import a library. Import random. Random.uniform is going to give the decimal value. I have to do this 3 times because I need the value for x, I need the value for y, and now for z. Hopefully it has created a tuple. If it is not any mismatch, and yes, the tuple has been created. Now I will like to show you how these solutions will look like. As you can see, we have appended a list. We have made a list of solutions, and each solution is represented by a tuple. A tuple has 3 values. This is the value of x, this is the value of y, and this is the value of z. These are random solutions which we are going to plug in to the fitness function to find its fitness. We have to rank those solutions, so that's why I have created a rank solution list. So I have to call each solution. I will going to represent it by s. I'm going to append it in the rank solution list. what I'm going to append is I'm going to firstly call the fitness function, and I will pass the values of x, y, and z. And I will also use the solution as whole. What actually I have done over here is that S represents the solution as whole. It represents one tuple, and the S of index 0 is the first value, that is of x. So I have passed it with correspondence to the variable x in the fitness function, that and the same way I have passed with the value for y and z variable. So the fitness function is going to return us the rank of the solution. S is the solution itself, and I am going to append this ordered pair in rank solution list. I'm going to show you how it will look like after that we have done creating. I'm just gonna delete this line code. So if I run it, you can see this is the rank of the solution, and this tuple which has three values represents the actual solution. These are the ranked solutions you can see over here. Now, as I have mentioned earlier, the closer the solution is to the value of 0, the higher rank it will have. We have to find the best solutions. For that, I will have to sort this list of ranked solutions, and then I have to reverse it. Sort function will basically arrange it in ascending order, and reversing it is gonna give us the descending order solution. But it will help us uh, it will help us to determine the best solutions with higher ranks, because in descending order the higher values come first and gradually they decrease. So the best solutions will be on the left hand side of this rank solution list. I am going to just delete this printing function, and now I can run this code. Hopefully there aren't any errors. Now that we have sorted the rank solution in descending order, what we have to do is we have to find the best solution. The best solutions are those of higher rank. Uh, since we had created 1000 solutions, we only want the 100 best of them. So I'm going to use the concept of slicing. And how I'm going to slice it? I'm going to slice the rank solution, and I'm just going to append 100 of these best solutions into the best solution list. Okay, so if I show you, I print out best solutions, so you can see over here it has already taken 100 best solutions. This is one solution, this is its rank, and this is the tuple itself. So after doing this, what I'm gonna do is I'm gonna create an array, a list of elements. And what I'm gonna do in this list is I'm going to append the values, these values, the values of x, y, and z as individual components in this list. Now our actual goal was to find the best solutions for this expression over here, and we have done this over here, but not necessary these solutions are one of the most best, one of these perfectly solutions of this expression over here, because let's say we have ranked the solutions, and the solution that has come in the first index, that is the best solution amongst all of these randomly generated solutions, but there can be s- any other solution that can be even better than the solution that we have just came up with. So for that, for finding the most optimal, the most best solution, the perfect solution for this expression, we have to create a new generation of solutions. And for that, I'm going to use the elements list firstly to extract the best elements from this tuple over here. I'm going to do elements dot append. Now what I have actually done over here is that S represents this one best solution. So this is basically the best solution that we have came up with amongst all the thousand solutions that we have generated. So I have firstly taken this solution, and by this index 1 I mean include ignore this rank and move to the tuple, and by index 0 I mean this first value of this tuple, that is at index 0 of this tuple. This represents the second value, and this represents the third value. So I am actually doing is that the from the best solutions I am extracting all of the values of those elements x, y, z, and I am appending it in the list of elements, because we have to create a new generation of solutions. I have created a list for new generation of solutions, and now what I'm going to do is I'm going to randomly just pick the elements from this element list. This element list has elements from the best solution list. 0.9, just a small change. It makes about, I think, 2% change. This is basically the process of mutation that I am doing over here. I have selected the elements from the best solution, and I am doing 2% mutation into it. So I have to do the same. Okay. Now I have appended and I have selected random elements. Now what I have to do is in the new gen list, I have to append this 1000 times. I have to append the new generation solutions. That will be, of course, it will be a tuple e1, e2, e3. So after that I have appended into this. What I'm going to do is the solution list is now going to be equal to this new generation list. This solution list that I have created down here is this solution list. What I want is to all of this process to run in loops, that it's gonna randomly, firstly gonna randomly generate solution. We are gonna rank those solutions. We are gonna select the 100 best solutions, extract elements, and then with a little mutation, we have created a new generation of solutions, which is again gonna get ranked, and 100 best are going to be selected from it after the sorting process. I want this all to be in loop. I have also placed an if check for the rank solution, that the solution that is present at index 0, if it becomes its rank becomes less than 0.09, the if its rank becomes less than 0.09, so I would say that since I am running all of this code in 10,000 loop, when this value is approached from the fitness function, I'm going to just return this value, or I can just stop this loop, and I'm going to print out this value in the code down below. So what I want is to make all of this in a loop format. I'm going to select it for indentation, because you know Python needs a lot of indentation to be done, else it might create problems for us. So the rank solutions, since these are the rank solutions, and if the rank, hopefully it should work. I have also decided to print out the solution of this generation for you guys to get an idea of what is actually happening. This basically represents the generation number, which I'm going to print it over here, and those rank solutions, sorry, it's rank sol. I'm going to print it out as well, so you guys get an idea of what is actually happening. There's a little bit of error here, and I hope there isn't any indentation fault. What we want to do is that we have to cut this piece of code, and I have to use it over here, because at this position the rank list was empty, and after it has been updated, now I can print out the index 0 rank. I also have to use another subscript, because this 0 represents the solution, the starting solution, and this 0 over here represents the rank in the ordered pair. So hopefully it's gonna run successfully. Please. Now actually there was a problem with this if check, that since 1 is being divided over numbers from 0 to 10,000, a randomly generated number, so it will be a relatively small decimal number, so that's why I had to make it even smaller for our rank to adjust. I'm just gonna run it, and as you can see, our solution has started. So now it is printing out for each generation the best solution that it has. each generation. So I think it has run, it is still running, and we are approaching solutions. So you can see over here is for consecutive, at least for consecutive 1 2 3 4 5 generations, we have a repetition of solution, that this solution is been repeating over and over again. So I'm just gonna stop this code from compiling, and I'm gonna copy this code from here. Now after copying that code, what I have to do is now I have to confirm that whether this solution is the best solution or not. What I'm gonna do now is I'm gonna take that expression, paste it over here, and I'm gonna print. And before that, I'm gonna do this: x is equal to sol 0, y is equal to sol 1, and c is equal to sol 2. So this is the solution that we have found. This solution is of exponent 7 power, which means that this solution is fairly small. It is 0.0000004, but on the negative side, but still this is so small value that it is closer to 0. This is the best, uh, this is the value that we have approached using this best solution, and our genetic algorithm has found this solution to be the best.